Hey, good morning, Free Heathen. Good morning, Robert. Welcome on in, everybody. This is a impromptu stream, wiring stream. A little chilly in the Dragon Den this morning. I guess let me start. Good morning, good afternoon, good evening, everybody. Welcome on into the Dragon's Den. My name's Digital Dragon, aka Luke. I'm a 3D printing variety streamer here on Twitch. Thank you all for joining me this morning. It's kind of a lazy day. There's no work for me today. We have a day off for my company today. Day for me, not the actual President's Day, but it's day for me, so it's mental health day. What better way of spending a mental health day than doing fiddly wiring, right? And by fiddly wiring, I mean wiring using these tiny wires that come with your SB2209. So the trick today, or not the trick today, is going to be to try and work on doing some wiring on the the SB2209 toolhead board, and more specifically, wiring up some end stops for our Filametrix toolhead. So we'll have an end stop at the top and at the bottom of our tool head. So before the extruder gears and between the extruder gears and the actual hot end. And this will help out in the Enraged Rabbit carrot feeder multi-material unit, specifically the Happy Hair firmware that supports it, to do some automated troubleshooting. Um, so yes, doing good, Free Heathen, doing good. How are you? MakerMind Nexus, welcome on in. Congrats to you, Dan. For those of you that haven't been aware on Twitter just yet, MakerMind Nexus, aka DB3D Dan, aka just Dan, has won a switch wire kit, I believe, from LVO Motors for their Year of the Dragon giveaway. That thank you, not thank you, but congrats, Dan. Um, you can stream as well too, my friend. Um, or I can raid out to you a little bit later. Either way works. I'm just gonna stream for a little while today. I don't plan on going like stupid crazy long. Um, yeah, you definitely got to figure out what color frame that you have or that you're gonna get, so that you can figure out some. That'll that'll be even better if they let you. I think what it's gonna be is he's gonna ship from one of his stateside distributors, so it'll probably be either KB3D or Rico or West 3D, and it'll be whatever they have in. Um, do I have time to chat about some cosplay? Possibly. I don't see why not. We can do some chatting while I'm sitting here trying to solder some fiddly things. So let me bounce the screen real fast here. Hey, welcome on in, Honors Danger Den. Um, Yeah, I woke up to my alarm. I stayed up a little late last night reading. Been reading at night. I drop things on Kindle, so I sit here and read on my electronic. And I've been reading a bunch of Halo stuff. Then I started reading some Gears of War. There's a break, like there's 8 books in the series for Gears of War. Books 1, 2, and 3 are online, and then 6, 7, and 8 are online. But 4 and 5 are print only for whatever reason. So I had to order books 4 and 5, and I don't want to start reading book 6 because there'll be a huge gap in between. So I switched over and started reading some Warhammer 40,000 stuff. Of course, it's a omnibus for Ibram Gaunt, who's a commissar, which is a political officer in the Warhammer 40,000 series or lore, and so it's like 1,200 pages. Read a little bit. Um, yeah, exactly. You can pick, that's great. Um, you know what? I don't know specifically what Storm Blaster um I want to do. So I've got the Imperial Mandalorian Commando armor almost completely printed. I did realize there was a few that I didn't print. So I need to get to work on that again and finish printing those things out. And that's one of the other things we'll start doing on stream is, acetone welding or some other type of joining for those things. Morning surprise stream. Exactly. It's an impromptu surprise stream, zombie. Um, but I did see that Galactic Armory has released a few more uh, uh, blasters, Star Wars blasters over the last few weeks. So I need to look at what blasters are available and see if I can figure out which blasters the Imperial Mandalorian Commando uh, troopers used in the Mandalorian series. See if that one's available and print that one to go along with it. Otherwise, I'll just print. Um, I did see the Shore Trooper armor set, and I wanted to take a look at that. I've got so much of the Galactic Armory stuff downloaded, and I'm just seriously looking forward to printing out some more of it, going that way. Um, oh, cool. Yeah, I'll let you know, Free Heathen. I'll let you know. But yeah, zombie. It's just it's a Monday morning. It's a fun day. I got 2 cups of coffee over here. I made a cup, and Mrs. Dragon brought me some from Dunkin'. So I always fill up a mug and then leave the rest in another tin. But today we're going to be working on, like I said, our Filametrix toolhead here some. So the way this is designed, and it probably would have been easier to install these before I put it all together, but we're going to have um, a end stop that goes here in a vertical orientation, and then one that goes down at the bottom in a horizontal orientation. And what we're going to do, we're going to use 3 wires, right? We're going to run 2 wires um, to act as the signal. So these will go to dedicated pins. And then we'll have a common ground, and you'll see these are the pre-crimped wires. It always makes it easier when you use the pre-crimped wires that Big Tree Tech gives you. But you'll see that I've got a break in the wire here where I pulled the um, insulation down, and then I pulled the insulation off at the end. What I'm going to do is I'm going to link this to both end stops. And my end stops, because the lengths of the pin and these go basically right behind this board. So you're going to have one that's vertical that's going to sit kind of like right about there. And the other one's going to sit horizontal down here towards the bottom. The pins are really long, so I've snipped the center pin out completely and then snipped the other 2 pins really short. That does show up on the camera there. So these other 2 pins are snipped really short and just enough to basically tack the wire to. Now, you got to look at the way that these go. So the top one is basically going to be put in with the plunger at the top, and then the bottom one goes in with the plunger towards the back. So they're going to be like this. So we're going to join the bottom peg of this side with the front peg of this side, and then the other 2 wires are going to be directly connected to the pin, and then I'm going to put them in the parts, or in the whatchamacallit, JST connector. So this top left connector is going to be the X-in stop. The bottom right connector, which is one I normally use for tap, is going to be my in stops for the toolhead sensor. And my tap on this one is going to get down here at the first 3 pins on the right of this 5-pin connector down here that's designated for use with the BL Touch. So we're using the servo side of the BL Touch. And so that's the way we're going to configure this and set it up. So also off stream, I did do some hot end swapping. So the Trident in the back corner here, Iron Dragon, the one that's got my logo and stuff on it. I swapped the hot end on that back to the Revo with the Obsidian nozzle. And I have gone ahead and put in the nozzle or the hot end that I was going to use here. I just got word they said that we're not there, even though they've posted about it, they say that we're still not supposed to show it. But yeah, this is nothing more than what you've seen on Twitter. So this is the drop effect next G hot end. And that's all I can really tell you, other than you know, it's done in conjunction with Fadus, and it has the same mounting hole pattern as a Dragon hot end. Beyond that, what you can see from what I just showed you is what you get. We'll talk about it more on Saturday because they come out with it on Friday the 23rd, and we'll talk about it more on Saturday. But there's a couple of people here in this group that also have that hot end. This is a beta version, so it's not the final package. It is an engineering box version. And there are some differences. So if you had one of those, you would put it on a V0. Really, Zombie? So I know Zombie and MakerMind Nexus got versions of these as well, but I know that several of the beta testers we did have some issues with it. You know, like I said, they're engineering beta test units. They're not the final, and we were specifically told to run them hard and do what we can to break them so that they can engineer out any issues and bugs. And quite a few of us broke them. But yeah, it is an amazing hot end. And I think, you know, there was no determination of who got what, but they went out with regular thermistors, like, you know, the N104, whatever, 104 NT, whatever, PT100 and PT1000. I got lucky enough to get a PT1000 version. And you'll notice on mine that it comes with the microfit connector, and I just created a microfit adapter rather than cutting it off to do that little stupid wiring for one of these. And I'm going to continue to use that. I am not going to cut those wires just in case I ever decide to put this on a different machine. But I will tell you, this is an awesome hot end, and I will be buying more of these. So with that said, we're going to do some soldering. And like I said, it is fiddly soldering because we're dealing with very small wires, very small like openings in the wire where I'm going to do that middle joint there. And I chose to do that rather than trying to solder 2 separate wires. Let me see if I can get this to show up. So this is kind of how I saw somebody do it on Discord. And you'll notice in the middle here, they did a little length of black wire between the bottom peg of the top one and this front facing peg of the lower one. And then they did a second wire joint up here. So you've got two wires going to the small peg. The problem is every time you go to heat that up to add the second wire, it's going to loosen the other wire. So you'd have to sit there and hold both wires together in order to get that solder there. And that's why I'm trying to just, one, keep the wire so it's one solid wire. And then two, this will make it easier just to do that little jumper by pulling that centerpiece of insulation. So that's what I'm going to try and do. I think it'll make it a little bit easier, and using the pre-crimped wires is definitely going to be easier. The other thing that I need to do is, this is the wire for the CNC tap. So this end goes into the CNC tap. Then they've got a standard JST side for the other side, which obviously is not going to work. So what I've done in the past is, this looks great until you're trying to put this bulkiness underneath the door along with all the other wires that are going in here. So snip the end off, take the insulation or the pretty coating or the sleeving off. So I'm just down to the bare 3 wires. And then I'm going to have to recrimp the ends with these tiny JST pain in the ass things. I've done it successfully a couple of times. So I'm going to try and do that again. But if I have any issues and I'm just starting to get frustrated, I'm just going to scrap the idea of trying to do those crimps myself, and I'll just solder pigtails on, with the pre-crimped wires and call it done. What else? I think that's kind of it. That's kind of the overview. I did also order and get in, oh crap. Wait, those are the switches. The isolation input, the isolated inputs that we tend to use on our borons. So I got that, picked up some more rocker switches. And this is important because we'll be doing this for the Trident as well. It came with the standard, we'll say the craptastic, what are they? The IEC 32 sockets, the standard all-in-one socket with the switch. I tend to like to run these instead. So I picked up a couple more of these to have, the one for the print or the Trident and one to have in stock. So we'll put one of these on the Trident and we'll have another one for our bench stock here. So DigiKey to the rescue on those things. And I have a tiny bit of a black box update, and that is, I got a note from KB3D. Apparently he's using my kit to kind of still help prototype the boxing up of the various kits. So I'll get mine here in it'll ship out in another day or so. I'm going to see if I can get this camera to come on. For whatever reason, I did some Windows updates and my cameras, this one, the main one, keeps freezing and disconnecting. And then this one I went to switch on the other day and it was just straight black. Whoops. See that? Yeah, so this one is still black right now. Don't know what's going on. But we can't go the closer or a close-up view, so we'll come over here as best as we can and do some of this soldering. But once again, we just need to make sure that we understand our orientation. And when you look at your part, and I'm not sure if I can get a good angle here, the ball goes at the top over here and the rear side over here. And so that's where you need to be cognizant of. So on the one here, it's going to be at the plunger needs to be at the top. So this will get our signal wire, goes to a numbered pin, and the bottom is going to be our ground. So we just need to know that when we go to do our soldering here. What I'm going to do is I'm just going to put these in my OmniFixo. And the thing I like about the OmniFixo is it uses these straight horizontal clamps versus a pivot joint for the clamp. So that definitely makes it a lot nicer when you're trying to do these solder joints. Especially when you do something like that and get a good pinch point on your end stops. And they're sitting on magnetic balls, so they can rotate around and really give you a good opportunity to get at the joints and things that you're trying to solder. So what I'm going to do is tin these ends and get my wires tinned, and then I'll come in and start trying to join things together. Yeah, it looks like a great little hot end for something like the Rook. I was running mine on my Trident, and I really like it. And the plan is it's currently got the 0.6 nozzle on it, and I'm going to run that on the larger Trident. And I want to say I do have a 0.6 Status hardened nozzle, or at least the TC nozzle, which is got the tungsten carbide for the insert. I was thinking about putting that on there. That would mean I'd have to, like heat it up. It's a standard nozzle, so you have to hot tighten the nozzle, and we'll see. I may just put the standard one on there, but I just have to be careful that I don't run abrasives through it. Ooh, torn cartilage in your right shoulder. So hybrid, is that something that hold on, okay, you are gonna need surgery to sorry to hear that, my friend. Sorry to hear that. Yeah, I've had shoulder surgery on the right shoulder for torn labrum, and then the left shoulder, this was a few years back, and then this left shoulder, I tore the labrum, the rotator cuff, and the bicep. So, hey Kenneth, how's it going? Welcome on in. We've just been chatting for a little bit. We found a great use for empty cardboard spools. I've used mine in the past. I've literally taken and zip tied them together through the holes on the Polymaker ones that you use to loop your filament in if you're not using a K2 clip. I've zip tied them together and used them as a stack as a camera stand. But right now, because they're all cardboard, I do take and recycle them. We'll take them down to the recycle center along with all of my boxes. But once again, I've cut the end stop pins down a good deal because we don't have much room. So there's the typical end stop pin to how I cut them down. Right? So they're cut down probably in a half to a third, and maybe more to a half. And I'm just going to get these things started, and I'm going to get these ends tinned, then we'll tin the wires, and then we'll start doing our joining method. And what I'm going to do is kind of get these set up so that this is going to be vertical, this is going to be the horizontal, like it's going to go into our uh, CW2 side of our extruder, and that'll make doing the solder joints so much easier when I start to solder up the wire. So my crunchy brass, because I'm pretty sure I will overdo it on some of the solder here. At some point I really need to make a fume extractor as well. Really doesn't take much to get these tinned, so just like anything else, just understand that you need your um, okay, heat transfers through the solder, so you need to make sure you have solder on the tip, and your tinning goes a lot easier. So we're going to kind of get these set up so I know which way to get these on there. I've got a long one, which will go down to the bottom wire, or the bottom end stop. I've got a shorter one that'll go to the top one, and then once again, I've got the black one that's going to join the two together. So let me, I'm really not stripping a lot at the bottom of this, just very little. Doesn't take much. And once again, we're just going to in these wires a little bit. And with these little wires, I find that if you get a little bit of solder onto your iron, you can tin the wires directly off of the iron. And then it's just a matter of doing a little, we'll say like a tack weld. Okay, we're just tack welding it there basically. We're going to do the same thing with this side. Except we're going to have to do it in two spots. Go ahead and end both spots. Center spot's going to be a little fiddly here. This is what I like about the OmniFix. Really get things lined up how you need them to be. Okay, so those two are joined together there. Now we'll have one more to tack together, and then I'll show you kind of where we're at here. These wires are so thin and they transmit heat so well that the uh, the insulation on them just kind of melts really quickly. That's why you really don't need to um, remove a lot of the insulation because it will peel back some. This is what we've got. So this one is going to go in the vertical orientation. This is going to go in the horizontal orientation. Got one long wire here, shorter wire here, and then this is a long with a break in it that we tack to both the, so the plunger's on the side with the signal wire, then the grounds are on the other side. That's how we're going to set this in there. Okay. So these are all good intact. There's a part of me that was thinking of running like a little bit of heat shrink tubing down here, cover the wires as they go. The plan is to run the wires behind the board and around the area right here with the mounting piece. So what we'll need to do though is drop a ball bearing. These should be 5.5 millimeter ball bearings. Yeah, you had an issue with the heater. Yeah, they had some issues, and the strain relief is in a very, we'll say, um, the orientation of the strain relief caused a lot of issues with people and existing mounts. So I know that they had sent a list out of things that they were changing, and I believe that was one of them was the position of the metal strain relief. I'm gonna grab my tweezers and see if I can get the balls dumped into the right spot without dumping them everywhere. Okay, one there, one on the other side. So there's our two ball bearings, one here and then one here up on the top side. And then we'll take our end stops and we just have to get them down in the slots and push them down into place. Now the lower one, so the top one kind of goes into a slot. You have to push down in there so that the holes line up, and then the other one just kind of sits down on the ledge somewhat, so it doesn't feel like it fully quote unquote slots in. But once you get it in place, you'll be able to put in your M2x10 screws to hold it in place. So there'll be the M2x10 self tappers. And on these, I am not going to use the ones that came in the kit because they're the ones that you have to screw in with a tiny Phillips head screwdriver. Instead, I'm going to use the ones that I have that use the socket head, the socket head cap screw ones that you can use a 1.5 millimeter to do. Hey, Nick, how's it going? We'll just need a few of these. And so like I said, we've got our ball in there, and then these two sitting in there. We're just going to screw this in place. Hopefully we got it lined up appropriately. Looks like it is. Now, once again, I didn't necessarily need to put these in to do the initial. However, if you don't, then there's an unconstrained portion in here that will cause you some issues. Now, this is where it gets fun, trying to get these two in to hold this bottom one in place. Right? All right, since we're going to be going into the housing first, I'm just going to move this out so it's easier to get the screw started, or at least in there. So we're going through the end stop first and then into the plastic part. And I just popped that off. So we'll have to be retacking that one. Oh no, I broke that completely. Broke that completely. What the? If you ever wanted to see what the inside of one of these look like, I just completely broke this open. And I have absolutely no idea how it goes back together. So it looks like I will be redoing one of these. Huh. Okay, so we're going to try this again with another install. Oops. That's a new one. Have you ever exploded an end stop before? Yes, this is the Filametrix. All right, don't know what I did there, but yeah, let me. All right, folks, give me 1 second. It's starting to warm up in here, so let me take my hoodie off. And yes, this is a quote unquote pain in the butt stream. So we did go to our Crimpin' Ain't Easy shirt. That out of the way so we can get back over here and do some more soldering. Heat that up. Once again, I'm going to cut the end pins down some so that they're out of the way of the back of the the SB2209 board. I'm just going to cut the center pin out completely. And we're going to have to redo this solder, which will be fun because this one's got to be done in place. We can remove our lever. No need to have the lever in there. What's this ready to go? Okay. That one ready. We just need to debond this one real fast with all. And this one goes where our plunger is. Going to go on this side. Then the other one gets joined to our other piece here. So turn it around that way. A little dicey now that I've got one already joined in there. Yay, and I did it without burning myself. That's a win for me. Got to twist around and get this put in place. Okay, kind of a little bit fiddly, obviously, and got that lined up. Now let's get this ready to go in. You need this shirt? Yeah. It's definitely a good shirt for doing these types of streams because, yeah, it is definitely a good case in point. Let me grab my ball end hex driver. Lined up, put that there, bring this down. What's going on here? I just broke another one. And I think the issue is the angle that's causing that to break. Started snapping that housing in half. Should still be salvageable though. So I may have to like super glue the housing together. So the screw head's going through. It's just trying to get it to angle into the printed part that I'm having the issue. So Yeah, I'm crushing things today, that's for sure. I am crushing. To see if I can't get these driven in some and then try and put that in place. It'd just be me trying to run threads in there. Yeah, I dropped my ball. Um, let's go ahead and take the door off. Get that out of the way and give me a greater shot at these screws. Yeah, the Crimpin' Ain't Easy shirt is definitely a good shirt to have when you're doing wiring days and fiddly wiring days at that. All right, so that's done. Let's see if we can get at this other hole and at least get the threads in the plastic started. Like I said, I think that could be the one part of the issue is getting the threads started, and you're having to go in at an angle because of the way that the printed part is. You're not able to go straight in from top to bottom. And that ball back in. See if we can't get this back in there. And like I said, the only other option I have would be to basically super glue this in place, which is doable, but would kind of make maintenance a little bit harder down the road. Okay. One in. Let's see if we can get the other one in. Yeah, I'm thinking the issue is the angle at which the screw head has to go in because of the hump in the around the drive gear of the well, the bearing for the shaft of the drive gear. So it's trying to get around this rounded piece right here to get these screws in, so they're going in at an angle and straight in. That's what's causing it. So running the screws in and tapping the threads basically gave us the ability to get these run in. We'll have to run these wires kind of up and around our um, mounting hole there for the SB2209, which yeah, yeah, make sure our wires are moved out and around the mount. In basically trying to make sure that the wires are pulled or pushed around that mount so that when we go to do our, tighten our screws down, that we don't clamp down and pinch wire, break a wire. Now, what I want to do before I go too much further is just put some filament through there and see if I hear the two end stops triggering. Hey, Nick, welcome on in. Yeah, this is a Nero 3D shirt, so we've got our thing loosened up, so we should be able to run filament directly in. You will see. I don't know if you guys can see, so let me, in the slot here, you should see that ball get pushed over. There's the first one triggering. Keep going down through the gears. And there's the lower one triggering. Probably can't hear it, but I am hearing it. There's our filament pop. So both of our end stops are triggering. So that's good. We will need to do our set our wiring. So we're going to look at the pinout diagram. We're going to look at the pinout diagram. Hey, there we go. And kind of hard to see here, but on this 4-pin connector, so it's the bottom 4-pin connector here. It goes from this side to the front. It goes 5-volt ground and then 2 pins. Stop 2 and stop 3, PB5 and then PB7. So what I want to do is the first one I want to put in PB5, the bottom one I'll put in PB7. So once again, understand the wiring and which one went where. Top one, the white one, was the lower one, and then the black is my ground. So we need to find our 4-pin housing. And once again, I cannot express to you how tiny these housings are, slots are. That's why it's easier to go with the pre-crimped ones than crimping it yourself. Understand which side is the, so if you look at the pin hole side, get it to show on the camera, they're offset to the top. Well, they're offset to one side. So you need to look at which way the pins are offset in the housing to know which one, how the pins go in. So the black is going to be the second one from the end. And make sure that you're, double check, get it lined up, make sure that you're going into the right housing before you push it all the way in. Because once you push it all the way in, you're not getting it out without destroying the housing. Or at least I have not. And once again, the next one will be top. end stop, which will be this cream beige, cream colored one. Then the white's going to be our lower end stop. And so there's our wiring, and this is just going to loop right over the top and plug in. And so that way we keep our wires out of the way. We can just easily loop these down. There's plenty of room back there. That one's done. Our X end stop, which is going to mount to the tool head, will go in this top left connector. So it's just basically doing another end stop with a length of wire. And what I do is I just use the full length of wire that's provided is over here. So I just use like one full length of this to do my initial pins, and then I'll figure out the length and cut it short. Once again, it doesn't matter, so I'm just going to grab first two that are here, peel them off. If you can get this extra crap off, then yay. If not, no worries. Sometimes if you try and get it off, it comes off easy, and then other times it will actually like literally peel the sheathing off of the wire next to it. And of course, that would be bad for electrical conductivity. So you can just leave it on there. Not going to hurt anything if it's on there. So, and once again, this will become the two wires that we'll use to go into our crimp housing. And our end stop is, so the 5-volt is towards the front of this connector. So we'll take our 3-pin connector, we'll figure out which way it would go in, and then we'll do our 2 wires. And the nice thing with end stops is if it's triggering wrong, it's real easy. All you got to do is just put an exclamation point in front of it, and you change the trigger from triggered to not triggered. Windows there, Windows next to it. So 2 wires in the housing. What we'll do is we'll figure out what length we need. We'll cut it. We'll pull the 2 wires back, and then we'll solder to a end stop. And that will be mounted to the back of our CW2. So we'll work on this in a minute. Once we can, basically I'll mount this on the CW2, and then we'll figure out the length for that. So we've got our end stop wire ready to go. This will be the next one that we have to work on. Once again, the smaller of your 2 connectors is the part that goes in the actual sensor. So this is the side we have to cut off. And we are just going to cut it off. If you want to keep the housing, you can depin it and keep the housing. This wire, I will tell you, is long anyhow. So just go ahead and cut it short. And then you can just pull the sleeve off. And this is a lot smaller, a lot easier to work with. You can probably just gently pull the heat shrink tubing off as well. These three are all joined together, as you can tell, so there's no issue there. And yeah, my preference would be not to put any super glue on there, period. So I didn't crack the housing all the way. The first time I completely separated the housing. So hey, Atreides Minis, doing good. The other thing I like is They do provide a thermistor pre-crimped for these tiny JST connectors. This is great if you're using a standard thermistor. In the case of the hot end that I'm using, it comes with a PT1000. So of course you do have to also take the Kapton covering off of this block of jumpers right here and set them appropriately. These lower two connectors, you have a 2-pin and a 4-pin. I'm using a 2-pin PT1000. So you set these jumpers accordingly, and then you go into the front 2-pin housing. If you had a 4-pin, you would go in the back and once again set the jumpers accordingly. Kind of hard to tell. See, there is a jumper set right there, or dip switch, I should switch. You just have to push those dip switches around with the tip of a tweezer or something. I got those set. This is set for the PT1000 2-pin that I will be using with it. So once again, we need to just set our I'm like, why is that not going down? Because you still have a screw in the way. Because we gotta put that back on there. So I'm fine with leaving this long because once again, if I fail on these crimps, the first time it gives me the ability to cut them off and redo them, or I can just solder in some jumpers and make them longer. Either way, no big deal. Just gives me room to work. So once again, on these three, we are going to try and crimp using the little connectors that they come with. And if not, we'll take 3 of the pre-crimped wires and just solder them on there, which quite honestly may be the easiest way to do it. But I have been able to do these crimps in the past. I am going to give it a shot. I will only switch over and do the solder if my crimping just isn't going to work for me. Yeah, so I think the solid fork and the micron, I have crimped the these tiny JST connectors and they're still working. But then again, they're not up and running and printing all day. In fact, both of them are sitting on the floor at the moment. But both of those I am planning on taking to Rocky Mountain. And then, um, oh, words sometimes. And then, yeah, we'll continue to print with those. I need to I need to get them up on a bench and start printing with them. So they may go printing out in the dining room or something again. We'll see. Mrs. Dragon leaves at the end of the month to go to uh, Colorado to help her mom. And so during that time, I can put some things down in the dining room because she's not here to yell at me about it. Um, oh, she'll yell at me, don't get me wrong, but she'll come back and it'll be enough time for me to pack them up and get them ready to leave anyhow. Yeah. So on these, we got to strip a little. And when you strip these, you strip a very little. Don't need much because these pens are so small. Strip a little off of all three. And like I said, I've done both where I've crimped them and I've just given up and done soldered extensions. Sometimes I use those pre-done heat shrink solder joints, butt joints, and other times I just straight up solder it and put heat shrink on it. But these JSTs, And you notice how many they give you. And yeah, there's quite a bit of potential use of these JST pens on the printer, but I think they give you a lot. And they started doing the pre-crimped ones because so many people were complaining about trying to do these small ones. What I have found is cut off one of these from the strip. Cut them off from the strip because they're too close together to be able to crimp them on the strip. But you need that little extra bit to be able to get these lined up and on there well enough so that you can put them on there. Because what I wind up doing is I line them up and I push the jacket, the wire down on the down in the area to be crimped. And then I can hold it in place with my finger on that metal tab. Turn it. This goes in the smallest crimp hole on our PA09. So that was the wire crimp. And do the insulation crimp. Next size up. Then once you get that done, then you can lift up, holding that connector, lift up that back piece, bend it off. That's how I've been able to do those crimps. I think that was a trick that I saw Steve Builds do. And of course, you know, give yourself a little tug, make sure it's stayed on there, it's solid. Maybe recrimp right at the back just to make sure that where you pop that piece off, it doesn't have like a little lip up. You just kind of rotate that out of the way and you can start working on your next one. Like I said, this is fiddly. This is the whole purpose of saying that this is going to be a fiddly wire stream. This is the fiddly part. This is the part where I kind of debate, like, do I need some like a magnifying glass or something when I'm doing these crimps? Be careful when you're doing that second crimp over the insulation, because if you crimp really hard, you will cut through the wire and the insulation and you'll be recrimping. Ask me how I know. Ask me how I know. There's two. Oh, need one more of these. almost like I'm getting a thing down. Yeah, the little magnifying thing that goes around your head and you can just flip them down. That's kind of what I need, is to find one of those. Um, Hey, 23 Blue Dude, welcome on in. Sorry I didn't notice you pop in. So what printer do you have that's down right now? If you're gonna say, you either need to fix it or get a new printer that's in that same price range, we kind of need to know what price range you're at. Okay, so that's 3 for 3. Now, one thing that we have to remember, and I've called this out a couple of times, and I'm glad to see that the manual here has identified it as well, is, yeah. Hey, Mr. Wizix, welcome on in. Ramon, welcome in. Um, so there's different wiring schemes on these. So if we look over here at our CNC tap through the mounting on, there we go, the wiring. So there's two different types of wiring. If you've got the red, black, yellow, you'll notice that the red is the voltage, the black is the ground, and the yellow is the signal. On the other ones where you've got the red, blue, black, like I've got here, the red is the voltage, the blue is the ground, and the black is the signal. Be mindful, because if you're not paying attention and you plug this in the other way where you figure ground is black and signal would be blue, you're going to blow your sensor and you're going to have to go get a new sensor. So be cognizant of that when you do your pinouts at the toolboard side. The good thing is the red is still voltage. That one they didn't mess up, but they did mess up the color scheme. And because these wires are, it's three wires together, right? They're joined. I understand that. Um, I can understand that, but it's still, you just have to be cognizant. I'm glad to see that they updated the manual. The other thing that I'm glad to see is they do talk about the connection methods. This is an update of the manual that came out in January, I think 24th or 29th. I do like the fact that they've provided this page here, because it says wire the signal output from the boron tap to the servo pin on the probe port of the EBB or motherboard. Configure the servo pin to be pulled down in software. That's critical. And then when the probe is stowed, the pin will be pulled high by the terminal or by the internal probe circuit. When it's triggered, the pin will be pulled low by the probe internal circuit. If a wire breaks, the pin will be pulled low by the internal circuit, thus triggering it, which will prevent you from crashing the tool head. The alternate method is to plug it into the to any other input, but the problem there is if a line or if the signal wire breaks, it's going to be pulled high, which will enable you to crash your tool head. So that would be the bad thing. Yeah, I always look at the PCBs. So I did buy, and I can't remember which show it was. Maybe it was Murph last year. I did buy some light bars. I haven't installed it on anything yet, but I will. But I did buy some light bars that I would show you, but I'm not sure where I put them now. Moved them somewhere. Um, but I bought some light bars from TH3D, and he specifically told me that they were selling them at a discount at the show, and they were really they had started to actually pull them and not sell them at all because the vendor that did the boards for, or that did the solid light strips for them when they sent them, they borked the wiring up on them. So the very similar to this, the wiring is wrong. So the signal or the power and ground wires are reversed. So if you don't pay attention, you could blow those. So yeah, just like everything else, I always look at the schematic to say what how is it pinned, and then when I do the other side, I want to make sure that I pin it the right way, right? So always a good thing to do. So what we're going to do is we're going to look at our EBB pinout, and it's hard to see here. Let me see if I can make this a little bit bigger, because we're going to look at the EBB pinout for the BL Touch. Okay, so we've got the BL Touch here. You've got ground, 5-volt, and the servo pin, and that's the part that pushes the pin down or drops the pin down. And then you've got the ground and the probe. That's the trigger pin. That would be a typical install. So we want to use those first three pins on our 5-pin connector. So once again, we're going to look at this and we're going to say, okay, the pins are high in the connector housing. So we'll take our JST connector housing, kind of line that up in there to see how it's going to go in. And then we'll see that the locking tabs are to the bottom of the housing. So it's just trying to figure out. And so we're going to go from the back side of the board, right side of my housing here. And I need to go ground first. And we know that ground is our blue wire. So that's the first one that needs to go in, is our blue wire. Find my locking tab and line the locking tab or triangle. Yep. Now next up is the 5-volt. We know the 5-volt is our red. Next we'll put in our red wire. A little bit tight getting it in the housing, so I'm going to try and crimp down on the bottom just a little bit more. Like I said, partly to get that little tab on the back where we broke off the strip piece. Make sure that that's fully flush and down. And then also make sure that we got a good tight crimp that will allow it to fit into the housing. There we go. And that third wire then is going to be our signal, which is going to go into the servo pin, and which will be what? EB6. Same thing. We've got a little bit of a bulge there still at the bottom, so we'll give this a little bit more of a crimp. Okay. All three are in. Oh, nope. Lock. You see if I can help it in a bit more. If you're ever trying to help a pin in, just be very careful that you don't stab the wire or yourself like I almost just did. Not locking it. Being a booger. So how's it going, Pez Liz? Have a good stream last night? I've got a little bit of a bulge on the side of the um, the crimp that goes around the insulation. And that little tiny bulge is making it too wide to go into the housing. Along a little bit and see if that will do it. Yep, that did it. All right, so we got all three wires in there now. And so once again, this will be blue, red, black at this end. Be able to go into the housing at the BL Touch connector down here. This will just wrap around and go into the side or into the sensor that will ride in the back here. And then we'll still need to cut our motor wire here, the length, and do the JST. This is just a standard 4-pin JST, so this will be a lot easier to do. Other than, of course, we got our wires, and we just need to kind of figure out how much wire length we need. I am going to leave a little bit of room there. If you get it too tight, you stand the chance of ripping it off the board here. Had that happen in the past as well. So good to just leave a little bit of room, and if you need to, it's always easier to make things shorter. But also, if you ever have a pin or a crimp fail, if you cut it very, very tight, then you have no way of re-crimping it, and you're buying a new motor. And that always sucks. Once again, There's some perfectly good wire that we can use for other things like, hey, I don't know, I need 5 pins to do my motor controller to the Arduino connection for the DO droid. There's 4 right there. Need to add one more wire and I can make that connection. So we'll hold on to this wire. We'll reuse it in other projects, whether that be for the DO build or um, the mini chopper. We'll use that for one of those builds. Whoops. Now I'm going to go back and grab that end because my assumption is that they at least have the 2 phases together in the right order on here. So if we follow that same pin out, we should be good when we do these. Now, because we're going to be using regulars, I want to take these tiny ones and put them away so I don't inadvertently use these instead. I do need to consolidate all these pins at some point. I have got so many of these little packets from Big Tree Tech for their different boards and stuff. So every once in a while I'll consolidate them into one package, and then I wind up looking around and I've got another 4 or 5 of these laying around. Standard JST connector in here. Yeah, Piz, this is just a impromptu stream just to do some wiring. I'm off work today, so figured might as well come in and do some wiring while I'm chilling out today. Could possibly do some work stuff, but I don't want to. Doing your Canadian music jams? Seriously? Rather than come off the installation just stretched. That's why you're seeing me try and manually get it off because it's stretched. There we go. There we go. Okay, that stuff's done. Under JST pins. So how's Kimmy doing, hybrid? I know that you got your new puppers. So hopefully your new puppers is doing well and enjoying its new environs. Holidays, the ransomware attack days. Yeah, well, and it's President's Day, so surprised there's not more of that going on. That's how this day. So, and this is the opposite of what I had before. So this is big JST connectors on thin wires, and I always have problems with these too, where you feels like you've under crimped, and then you try and crimp again, and then you cut the wires when you go one size smaller. Sweet as ever. She's getting a great little pup. Yep. Really hope she's not a boxer breed. Why is that? Oh, they get big. Yeah, I can understand that. That one I had a couple of wires that got away from me. So continue with that one. We'll redo that one. This is the way it works. Every time I get the right number out, I tend to, and put everything away, I tend to screw up crimps, and then I need more of the connectors. Okay. Definitely not a day. Yeah. Yeah, don't tinker with electronics when you're half asleep. Don't tinker with electronics at 2 a.m. unless you're on a night shift and you're always up at that time. Bad things happen at 2 a.m. Bad things happen at 2 a.m. What I'm doing is I'm going through and I'm going to do all my crimps, and then I'll come back and insert them in the JST connector. That way, if something happens and I have to cut an end off, um, need to actually do a longer amount, I can recover on all sides just by cutting and reterminating it. One wire really short, and every once in a while you get a crimp that does what that one just pulled over on it. So in this case, this happens a lot with me when I'm doing the larger JST connectors with um, smaller wires, normally on motor wires, where the length of the lower crimps that go around the insulation are just way big, and if you're not careful, they'll fold over rather than curl up, and then you wind up with an issue. So not the best crimp, but it's still salvageable and serviceable. So go with that one. Yeah, don't work on electronics after some wobble pops either. It's been a while since I've heard wobble pop. Yeah, so I'll say the more ubiquitous would be the EBB 36 or the EBB 42. So the EBB 36 goes on the round motors, like your V0 or an orbiter or something like that, where your EBB 42 is sized to go the same size as a NEMA 17 stepper motor. Those are, I'll say, the more versatile boards, where the SB2209 is really designed for Stealthburner. Um, but be careful of the SB2209 that you get. There are different versions now. There is a standard SB2209 with the STEM 32 chip, and there's an SB2209 with a Raspberry Pi 2040 chip. Now, the Raspberry Pi 2040 chip, the crimps are easier to work with. However, you do lose a couple of potential outputs when you're, uh, so just be cognizant of what you're using it for. and whether or not you need the additional output. But going to the Raspberry Pi 2040 did enable them to get some space back on the board because they won't have as many outputs. And that enabled them to use some bigger connectors. So just be aware of that is kind of where I'm going. Okay, so what I need to do is get my orientation here, and then I'm just going to use the same order for pinout. Green. Bring up with a little nub on the side. Okay, so green, blue, red, black, green, blue, red. Okay, so line up in. Okay. So we've got our motor in there now. We can just take this wire and kind of push it back, put it down in the little gap between the back of the motor and our um, whatchamacallit, the normally it'd be cable chain, but this is going to be, there'll be a piece that sits on here that supports the EBB36 connector. So those are in place. We've got our cable for our X in stop. And this is going to connect right here. And this is just going to kind of run right down and then around the back to the in stop. In fact, I'm probably just going to connect this up the way it is and call it good. To an end stop that we can install here in a minute. Which would be the middle pin. Ground. Down just be another in stop. I can't remember if these came out of the kit or if these were mine. Doesn't really matter. I've got plenty of them. We do want to keep the lever on this, and our lever faces down, not up. Always facing down. Once again, our plunger is at the top, so the top will be our signal pin. Bottom edge here will be our ground pin. So we'll make sure and connect those up right. I'm not going to bother about cutting anything off. It's not going to be in the way. So it's just a matter of getting this into our thing here, getting some solder going, and we'll get this soldered up, and then we'll get this ready to go on to our under our tool, or the tool head, the CNC tap. Do the same thing as before, clean the tip, and in the two ends. These wires should be pre-tinned. The one's the ground, and the ground is the furthest plunger. Go ahead, sure that we're hand drill good on these though. Felt like I had too much solder on that. Much enough. Anybody else find soldering end stops pain in the butt sometimes? I hope so. I hope it's not just me. End stop is wired up. We'll be able to mount this on CNC tap. And I think we're good enough now, wiring wise, on that we can move some stuff out of the way, bring our printer up here, and get a couple of things installed. We're not going to install a lot. We're just going to basically set the basics of the tool head up. Now, we still need to put that on the tool head board. That's a sensor, or the end stop. Okay. Do need to put our heatsink on. So the SB2209 is on this side. So we're putting the heat sink right on that little gold pad. So I think what is the difference on the 2040 version of the SB2209? Is it just the number of in-stop or available pins, or was it did it drop the? I think it dropped the ability for a PT100 1000 thermistor, didn't it? Which I've only ever had one of those, and that's on the uh, beta toolhead I'm using. I have a Rapido too in the K3, and I want to get a couple more because I really like that hot end. This is a pretty tight fit. You make sure that you get it in there and that you don't have that heat sink hitting the capacitor or anything else. That's good. Whoops. That's good there. Uh, get our Omni Fixo out of the way. Head, coffee cup. Bring our printer back up here. Okay. So, what are we going to start with? Got our top of our tool head here, which has our SB2209. This is all I really wanted to install right now is just to put this back on here. This goes on with some M310s. This is going to get it again. Have to get that in place. Got plenty of room for the driver. We just need to get the screw started. Sorry about that. This side, screw on there. Run it through the hole in operation if you've ever played that game. Oh. Um, so initially we're going to just install this as a standard tool head. Um, it'll have extra sensors in it, of course, but the end goal will be to build a Enraged Rabbit carrot feeder 2 and use the Happy Hair software with that to install it. What we're doing right now is we're just doing a couple of little tidy things. So we've got that installed. I'm going to turn this. How best to do this? We'll turn it 180 degrees now, so we'll look at the back of our tool head, which will be a little bit hard since we've got the thing here. So let me see if I can place some angles. Okay. So once again, this is the sensor for our tap, and this goes in only one way. Of course, requires me to twist it. Get this lined up and pushed in. Right? And then we'll just take this and kind of fold it up and out of the way. We've got our wires up here for our 2 end stops in the front. We will we'll have our thermistor that comes up, our heater that'll come around. We need to install our end stop. The mount's already here. All I need to do is unscrew the 2 actual end stop mounting bolts, which are pre-installed in the housing. Make our lives easier. Why are power LEDs red? Um, they'll let you know that there's power and red is dead. And at least DC voltage wise, your power is normally red and ground would be black. But you can get it whatever color you want. You can get it green, you can get it blue, doesn't matter. Where did I put my end stop? Once again, our end stop is going to be mounted facing down with the lever facing down. So we'll just get our screw started, get it lined up, find the screw hole. Easier said than done sometimes. Yeah, I think a lot of things people started going with blue for a lot of lights just because it's a softer color, blah, blah, blah. I don't know. Now, what I want to do is slide this over and make sure that it triggers against the housing before it bottoms out. And it does with about 2 or 3 millimeters before the carriage hits the side rail. So we're good there. Now this wire, I'm going to bring it around and then up the side and plug it in. Just kind of just like that, right in front of our belts, or even between the loop of the belts, just to kind of keep it out of the way. And like I said, we just kind of tuck these wires in underneath the housing when we get the housing. Speaking of getting the housing back on, let's go ahead and turn this around so I can crank on this a bit, and we'll tighten the or get the our cover back on. Okay. Once again, these wires will just tuck up underneath there. This will come down and we'll latch it down. Like normal, your tool head of choice. Once again, I do have some extra long wires here because I didn't want to trim this down and put a connector on it. Once again, it is my only PT1000, so I wanted to keep it in its stock manner, so I just made a pigtail for it. Makes it extra long, but it's extra long, no big deal. And this is a beta version of the NextG toolhead that we will talk about more on Friday, or Saturday, I should say, when we're allowed to. Right now, I can show it to you simply because, well, they've showed it on their socials. Oh, like, why is that not catching? I don't have my M3x6 screws down here for it to sit on. Let me grab some M3x6 screws. That would be why it's not sitting there. And these go in the very bottom holes. And I've never had these loosen on their own, so there's no real need to do any Loctite on these. They're just there to provide a little shelf for your tool head to sit on until you get the main bolts in it. Oh, hey, Wind Farm, how's it going? But yeah, our cutter's there. Put these wires around the back side. Line that up. I think this is just these bolts are just way loose. So we'll do add another turn. You don't want these so tight that it pulls these pulls the top in and juts the bottom out, but you do want them so that it doesn't fall out like that. There you go. Just needs to hold it in place until you get your main bolts in. We haven't test fitted this since we've got our wiring in place, darn it. There you go. Need our kind of tight there still for whatever reason. Bolts, bolts, bolts. There's an 18 that goes on this side, then the normal. What size bolts do I? 350s for the bottom, 25 and an 18 for the top. And I'm just grabbing my own hardware, 25, 18. I know there's hardware in the bucket for it. I just easier to reach over and grab mine. So this top left one needs a shorter screw. Because of our filament cutter here. Uh-oh. Give me a second here. Something's not up. Hmm. Oh, what's not lining? I don't think I checked to see if, I think that's what it is I got plastic spout threads there maybe. No, it's going in now. Oh, what's going on here? Got a little bit of alignment issue. Something is not aligning right or fully. Well, I think it kind of sucks about Stealthburner. So many parts, and you're going through multiple pieces that if things aren't lined up just right, um, it just doesn't line up and work. Something isn't lining up. Lines up on the one side, but not on the other. One's going in, but this side reason is now it is. Okay. Hmm. Oh yeah, most definitely tool design. I'll agree with that statement. think it's something in this bottom piece that is forcing us out of alignment a little bit. Just feels like it's slightly out of alignment. You guys ever have any problems getting your stealth burners to go together? I was able to get it to go without the bottom part in, but as soon as I add the bottom part, all of a sudden something's knocked out of alignment. Finally lined up. Nope, it did not line up either, did it? Hopefully I didn't just screw up a bunch of pins. Yeah, there's something in the bottom housing that's causing that not to line up, and I sure shit did just bend the hell out of a pin. Righty. Damn it. Why is it that this is lining up, but as soon as I put the bottom in it, I may just need to do some filing on in the lower housing front. Just to give me, I think it's just some shrinkage between the two, this component and this component. I think there's a little bit of shrinkage there. So if I go through and sand down these edges here, it'll probably make it fit a little bit better. So sand down these cutout edges some, and maybe just this face down just a tad. That should solve the problem, fitment issue. Oh no, may not be it at all. It may just be a wire that's sticking out. May just be some excess wire right there sticking from our LED. I can push that down. Okay, that was it. That was it. There was just a little bit of wire sticking out from the LED. That was causing the misalignment. I believe. So that goes in place. Pop in. It's still not lining up. If I can get the left side to line up, no problems. Right side is being persnickety. Alrighty, we'll have to work on that off the yeah, it's still misaligned and I'm trying to figure out what's causing it to be misaligned. I don't know why this darn thing is not latching and up there. Now it's in there too tight and it's pushing it out. Once again, I take this completely out of the way. Put this on. Line up, maybe. Plugged in. Goes in with no, oh, no, it's not going in either. So are these off? I don't think there was a different, well, no, there was not a different front housing um, in the files. There's no different front housing in the files. But for whatever reason, it feels like I am digging into plastic instead of into the screw. That just went straight in. I think. Nope. Yeah, loosen the tool head board and let it kind of self-align a bit. That definitely could be it. I always have a tendency to ugga-dugga those things down, so that just probably is it, where I just, this is too tight, and so it's causing the, can't see it. Yeah, let's see if that helps. Oh, and you'd think if you get one side in that you'd be able to get the other side aligned and wouldn't be a problem. That side's in. I'll be damned if that doesn't feel like it's hitting the plastic and not, no, nope, it's back out again. What in the name of God is going on here? Yeah, I'm just going to have to file down that part some. That's the only thing I can think of. Because once again, if I put it on there without this, I believe it lines up pretty darn good. And Well, still not. Oh. Something ain't. Yeah, the screw goes in without the blue part. The screw goes in fine. It's a misalignment, right? So the screw's going in just fine. It's a misalignment where it's just ever so off and it's hitting the plastic. So I don't know if it's like shrinkage or if there's a slight misalignment between the stock housing and where this gets set because it is a little bit high here. So I'm wondering if it's something to do with the board itself. So this house, the CW2 housing is different for this CW2 housing is different for the ERCFA, right? To enable those sensors. But the front shroud supposedly has not been changed. But even loosening that up, it seems like there's a little bit of a misalignment in these parts. So either my shroud has, you know, shrunk and caused issues or something because as I go in, it's like, okay, it feels like it's screwing in, but it's not. It's not lining up. So there's something that's still misaligned. Yeah, well, I just loosened this board up some, so it should have a little bit of flex and move to it. Now, my question is this board here, is it somehow screwed too tight and bowed or something? Or does it need to have a little bit of movement ability in it? Because between both boards, they should have, they should align. Did we get the right mix finally? Uh-oh, we may have had, it was possibly the fan board was too tight. It was causing it to bow. So I loosened the screws up holding the fan board in, and maybe we had the fan board bowed. All right, now because it should not be that hard. And there we go. So I think we just had the fan board too tight, which was causing the misalignment of the front shroud. There you go, people. Don't ugga it down too much. You'll cause your own set of problems. Okay, that goes down there. Thank you guys for helping me troubleshoot that. I do need to get to my other wires, my screws is what I'm trying to get to, because I need the M3 by 50s for the bottom, and I don't have any of those readily out. So 40s, M3 by 50s. It did call for M3 by 50s or 40s. Yeah, M3 by 50s. None in here. All right, well, let's see if we got them in the other step or the other box. M3 by 50. Yes. Do enough builds and you get plenty of extra screws. Yeah, it pulled up nicer on the side there, so just to get these in there now. Pushed it out. Like these would have done good with a little bit of reaming. Oh, there we go. Just a little bit too tight on some things. There we go. Something's a little too tight now and the cutter is not. Not sure how far the cutter goes. Might just be that it's too far. I think we're going to be winding up playing with the cutter itself a little bit. 'Cause if it gets pushed too far, it sticks and it doesn't pop back out on its own. So, so what I mean here is like if it's just doing this, it's good. But if it pushes it in too far, it sticks. So it's going to have to be but really, I think if it goes like right there, it's done its job. That'll be something we have to look for, look at. And the cutter piece, this piece, is going to mount right here at the end of these last two screws. We'll have to take these out to mount this. And I want to say that that was going with M3, was it 12s? 10s or 12? M6 with no backers, M10 with the titanium. Wait, no. Oh, yeah, 10 because we're using the titanium backers. Yep. So we're good there. We need to replace these with M3 by 10. All four socket head cap screws. We got 10s in here. We have 8s and 12s. No 10 millimeter socket head cap screws. So we'll grab a couple out of my stash. One of those out at a time. Okay, and that's moved over as far as it can go. So this will be the furthest point. Basically, this will come over, and we need to make sure that our plunger will line up with that mark. So we're high, so we need to drop this down a couple. Through that, drop it down to the right height. That back up. And then we need to be the right distance pulled out to the front. So we're going to unscrew this. If we need to, we'll add a, we'll do a longer screw. Yeah, we're going to have to because this isn't long enough. We did call for button heads, so Do I have any long button heads? The answer to that is not in that kit. In mine, I know I do. What are we replacing? We're replacing a M3 by 25. .35 gives in millimeters. With an M5 by 30. And all we're going to do is just line this up with the notch in the cutting arm. That's there. Oh, wow. How does that work? I thought it was going here. It can't. It has to go over on this side and point that way. Because otherwise, there's no way it's triggering. And so once again, there is no documentation on or like CAD or anything that shows how this stuff lines up. So I am kind of just winging it and trying to figure out where it would line up at and where it would go. This must line up in the back here. Like I said, it's telling us what screws to use, but it's not telling us where to mount this at. This is the only thing I can think of is that we mount it all the way in the back here, and we're going to use a move to tell it to come back here and then run up against the thing over here. So can come back, can come over, and that's going to hit. And as it comes over, it'll push in the cutter. And that is the right height where it will pick up that button head cap screw, start pushing it in. Yeah, that works. We still have a good amount of travel, so I can swap this back out with the other, um, with the one that it called for. So has anybody else put together the ERKFA V2 or V1 with the toolhead cutter? Because I'm assuming you don't need a V2 for the toolhead cutter. Okay, Urban Monkey. Yeah, like I said, I've got all the printed parts done. I just wanted to do the tool head as part of the build so that I didn't have to tear the tool head back apart and redo the tool head. Okay. Because I prefer to just build the tool head once and not have to go through this with different parts because, there are a bunch of different parts if you go with the filament cutter or not. Um, so I'd much rather have it put in place now, which we do, than have to swap tool heads over. Okay, so in all of our wiring here, we've got our X in stop that comes up, and we did validate that does trigger before this gets to the end. We're going to have our thermistor wire, which is going to go right here in the front of the little 2-pin connector here right at front. It's going to be still a pain in the butt to get in and out, just because of the size of the connectors. Okay, and then I'm just going to tuck this up and out of the way. Our tool head power comes around the back and we'll plug in like that. And then all of these wires will just get tucked up out of the way and underneath. However we can make them work. I have to print a different door. There is a couple of different doors that you can print out as well. I'll probably have to print out a different door that gives me more room underneath. Yeah, it's just going to cramp everything down on there tight. I think I'll have to look at a different door possibly. Either that or we're going to have to route this stuff down low, out in the back maybe. Yeah, there we go. Which I'm fine having some stuff out the back if I need to. Once again, I want to keep that stock thermistor piece there. I'm not going to close the door yet because we are going to need to get in here. We do have to get to our boot and reset pins, and we'll have to add our 120 megahertz or 120 ohm resistor in there, which we could probably do now if I can find the darn thing. This, this back in here. Where's my SB2209? Oop, there it is. This one. I think I had already dumped the um, I think I may have dropped the particular jumper for that phone, or it might just be that it does use one of these. I'm missing the right jumper that I need. So there's a jumper that has like a little tab on it, I'll say, and that's the one you want to use for doing your 120 hertz, just because you have to move it around. You'll put it on the 5-volt jumper so that you can power your board with a 5-volt USB cable, and then you'll switch it over to your other cable afterward. And the difference is, I can find the jumper. Right jumper. Or maybe in the newer ones, they switched it to a different jumper, which will really, really sell. Yeah, they must have changed it out and swapped it. So that's the jumper they're wanting us to use. There's another one that has like a longer tab on it, similar to what you get on the UTC, that is so much easier to use. Now, I say that, but let me double, triple, quadruple check that I didn't actually stick it on the 5-volt jumper already. I may have done that as well. You never know with me. Of course, we got a rubber ducky. Always have to have your rubber ducky. Make sure he works. Rubber ducky works. We'll have our CANBus cable that we'll definitely use to do our install. The rest of this we'll just toss in here and put down here with the rest of our excess parts. Okay, let me take a gander and see if I've got that jumper on the 5-volt already. And I don't. Well, that just stinks. So you've got a 5-volt jumper back here, and then you've got another set of pins back here that you would jumper for your 120 ohm resistor. So you put one jumper back here, do your USB cable, and do your configuration. Then you'll remove it from this and put it down here when you use your standard uh, CANBus cable. So, what else did we want to do? Like I said, this is kind of an impromptu stream. I wasn't going to stream all day. I just wanted to stream a few things. Um, as you can tell, I did run some wires down the side. I'm going to flip this over. And all I did was I ran our motor wires down and around some. Let me raise you guys up so you can see what I'm talking about. Um, so I went ahead and let me see this one. So I went ahead and laid out my um, wire management stuff. So there's one central one here, and then smaller ones placed between the den rails. Um, B motor, Z motor, B and A motor have been run down and just plugged in. I didn't do anything other than just plug those in. This will be the Y in stop. I need to crimp and create the terminals and then loop it over and plug it into the Y in stop. No other wiring's been done. The bed wires are just kind of sitting here. The bed thermistor wires are sitting here, and these are going to have to be extended to be able to make it over to the thermistor connections. Let's see what else. Um, I do think my wires that come down the sides, I'm going to take the twist lock tie straps out, and I'm just going to press the wires into the channel with the channel cover. So I think that'll look a little bit nicer. The wires down here are just, you know, I make them pretty if you've got uh, channel covers. So we're not making them like super duper pretty. I'm not cutting them any shorter than they need to be. Um, that's kind of where we're at. We can continue wiring. Like I said, this is kind of an off stream. And really, if we get the wiring or a lot of the underdeck wiring done and stuff, then that means Saturday will be closer to just doing some basic print. And I just want to push plastic and make sure that everything's good in the tool head. Once we validated that we've got a basic configuration and everything's good in the tool head, then we can start building our Enraged Rabbit carrot feeder and get that going. And the Enraged Rabbit carrot feeder is going to, um, oh, words. That'll be a couple of build streams to get the Enraged Rabbit carrot feeder done, the Enraged Rabbit cottontail done. We've already got the tool head done, and then it'll be really just working on software configuration. So okay, you're going to do the IRCFA 2 and the cottontail on your Enderwire. Nice. Now, do you have your Enderwire enclosed or not? Okay. Okay. Um, Now one thing that I do need to do is make note of a couple of things. So, and this is for software configuration and a little bit later. Um, and like I said, we can continue to work on some wiring. We can do some of the wiring, just 110 wiring and stuff like that. But before I forget, I do need to make note of what pins we used on our EBB 36 or EBB 2209. So our in stop for X, so X in stop is using EB6, EB6, and our other two end stops in the tool head, we went on the 4-pin end stop connector. And so we had PB5 and PB7. And we just need to understand the names for those. So on the, trying to think where that would be documented. Anybody know what we call those two end stops? Not showing them in this cutout. Must be under the main ERCFA V2 document. Build guide. Oh, blasphemy. I haven't downloaded the repo, or at least not on this computer. I didn't. All right, that's going to be your PLA TPU machine. Okay, gotcha. Yeah, most of my stuff is enclosed, as you can tell behind me. I just, most everything behind me is enclosed. I've got the Mark IV that's down here underneath Cyber Dragon, and that is wide open. I've got a Ender 5 Plus that's converted to a 0G Mercury that's not enclosed yet. And I use that to print my helmets and other large cosplay items on. That's 370 by 370 by 420, I think, build volume. And then the Ender belt, and of course the Prusa Mini art. So I've got plenty of the machines back here that I can run engineering grade materials on. I'll be doing a Trident 250 with side pack. IDEX or something. Well, I don't like a Trident 250 made into a Tridex. I think you lose a decent amount of build volume doing that. Um, or I don't know if you'll have to, I'm not sure. I haven't looked at the Tridex, but I think, don't you have to build it in the next size frame up to enable? Yeah, not if you extend the frame, you'd have to modify the frame. Yeah. So, okay, so we're download. Track that out. Okay, so the ERCFA build, what was I looking for? I'm just looking to see if they talk about the tool head and what those tool head sensors are. Unless somebody knows what they're calling those tool head sensors, just so I can make my notes appropriately. Tool head sensor, set of modifications for popular extruders. Okay, that's great that they got it. Like I said, yep, tool head sensor. Then we go right in. Yeah, I know they're micro switches with 5.5 balls. I'm just trying to, because there's two up in the tool head, I'm just trying to figure out what they name each one. Might be um here we go. Entry sensor and tool head sensor. That's what I was looking for. So entry and tool head sensor. And partly I wanted to make those notes because probably um in the Happy Hair software, they're going to be calling them these same things. And that's why I wanted to make these notes so that when I'm going through and doing the configuration, I can set those up as appropriate. Okay. That's really what I was trying to do. Ball one and ball two. Guess what I need is more ball talk on the stream. What did you do today? Well, we loaded our balls, we named our balls, we played with our balls, we dropped our balls, we fixed our balls. Um, yeah. So I'm going to move this over, and we're going to kind of come back over to the Trident build, and let's work on a couple of things. Now that we've got um, our inlet wires, see if there's, and actually based on, yeah, once we install the inlet and then install this, and you can see that that starts getting tighter. And since I put this piece here, it's going to get even more tight. I'm going to hold off on putting the switch in place and just start doing all the wiring. Then I can add the switch with the final three wires. And I think that'll make my life a little bit easier. And of course, they show neutral and load and then ground. And I've got my load and neutrals. Well, I have to remember that. I don't think I'm going to get these out of the bracket without busting something. X and Y end stop. X is on the tool head. Y is mounted on the back. Both of those click before we run out of room. You have the jumper set up on the board appropriately. There's no 110 power switch on this. It's self-sensing. We can set this up. We're just not going to install it just Let me put some things up and out of the way. Got the switch, got the wires, the part that we'll need is where? Nope, not that one. There we go. We'll need this part. We're going to need to put in a couple of heat set inserts, so I'll do that real fast. And then what I'll do between now and the next stream, well, I was going to say I'll go through and put in the rest of the heat set inserts for the skirts. Give me something to do a little bit later today. Actually, I got to do some cutting for this is dragging later today. Making a big, a big pink ribbon. Somebody at my mom's church for breast cancer awareness. So I think what I may have just been hearing was her putting the stencil on the wood, and then I'm going to need to take it outside and cut it out later. So we've got our parts now. Got our parts, and once again, our under the deck wiring kit by Lineo. I love these because it has everything that you need to wire any of the Vorons underneath. It includes the Wagos, it includes JST connectors, some spare wire in case you need any. And then you've got like safety ground from the frame to the DIN rail, PSU to controller wires, SSR wires, zip ties, power inlet Wagos. So this would go from the power inlet to the Wagos. That's what we're going to be looking for here. You'll have your 3 wires that go from the power inlet to the Wagos, and then the 2 wires with the isolated terminals on each end that will go to the from the inlet to the switch. And these have come down a little bit, so I'm going to look at the way that it's installed there, and we're looking at it from the back. So I believe these were M3 by 6 screws. I should have some flathead screws that I can use for this. One of these. M3 by 6 flathead. Yeah. Like I said, I appreciate everybody that's been hanging out with me today. I know it's kind of a lazy day. And, it's weird for me to do a midday, midweek, or a midday, midweek stream or weekday stream. So probably be better if I use like 8 or 10s. So I'm going to pop these out and I'm going to grab some different flathead cap screws. Maybe. These just don't have enough bite into the pieces for my taste. So we'll go ahead and do some M3 by 8 or some M3 by 10s. I've got plenty of them from the Droid build, so that's no big deal. Droid build. Move them over. Screws. Where's my screw? Move them over. Screws. I've got project piles laid everywhere so that I can continue on the projects that I've got in flight. It just means I've got piles of things everywhere. We're going to do M3 by 10s. Give me plenty of length to get into the screws or into the nuts. The inserts. In this case, 8s would have been fine, but 10s work and they don't protrude out the back of the plastic, so we're still good there. There we go. And we'll need our switch. And make sure that our switch lines up. And once again, one thing to understand is which way. So the heat set insert side is the bottom side. And I always want to make sure that off is down so that I'm reaching around behind and I'm just flipping it down. Okay. And that breaks off. Okay, so you always want to check most of your switches. These, of course, not, but on your other um, switches, like your standard IEC sockets that are switched outlet, the switch can come out and be turned around. One of the things that you want to do is, I'm looking at the instructions, and this is the way we're looking at it right here, and it shows the switch going in with the pegs at the top and in the middle. Right? So I'm just going to set that in there, but I'm not going to push it in yet. Now I'm going to turn around. Once again, this is my bottom where the heat sets in, and I flip it over and I look at the switch. I want to make sure that the switch is down in the off position. Because this is going to be in the back lower part of the printer, where's my mouse? So as you can see, all of my printers are back here and they're kind of tight fits. So what I want to be able to do is reach behind here without looking and flip down if I'm turning a printer off. So if there's any issue whatsoever, I need to kill power immediately. I want to be able to reach quickly behind it and just flip the power down, the switch down. So I always want to make sure that down is off in the orientation that this is going to get mounted before I push it into the part, and then just push this in until it clips. And there we go. So now what we can do is we're just going to get our wire set up. So it's the outer side of this to this piece here, fully seated on there. This one comes around and gets fully seated on. We're going to do the same thing with the red. Red's going to go next to that one. Make sure it's fully seated in there. Red's coming over here now. Once again, make sure that it's fully seated up in there. Whoops. You want to make sure, like, that may feel tight, but it's not. You want to make sure that it's fully seated in there so it's not going to come out. All right, then we can get our other 3 wires on there. So blue goes over blue. Red will go over red. And making sure they're fully seated. Green goes on our other remaining terminal, fully seated. Now we would be ready to mount this back here. But once again, I want to do the rest of my wiring back here. So these will be the last wires that I bring in and plug in. That way I have free reign to get to those connectors. But I did want to get that connector done up. Now the other thing you want to do is just verify that whether your outlet has a fuse in it already or not. Sometimes they do, sometimes they don't. I did order fuses, so even if there's no fuse in here, I can put a fuse in there. Probably would have been better to check this before I mounted it in here. And no fuses, so we do need to add fuses. Like I said, I did buy fuses, so I'm not sure if we require both fuses to be installed. I always put both in there. And more so to just ensure that they're in there. Okay. The fuses are installed, which is good. And I always buy spare fuses when I order from DigiKey so that I always have some spares in case something goes wrong or I blow a fuse, which I haven't done yet, but I'm sure it'll happen at some point. Sure, it will happen at some point. Another set of filtered outlets for use later on. Okay, now we're just going to keep working through what we have here. We don't need the 5-volt to PSU because, well, we don't have a 5-volt PSU. We've got the PSU one, so this would be from the Wagos to the PSU. And I'm going to turn this around so that I can see my PSU wires better. Once again, this is my 110 quadrant over here, and then everything on this side will be my 24 volt. So we'll have ground, neutral, load. So your load is your red cables. Now, these are bare wire. In your Wagos, you can do bare wire. There's nothing that requires you to do barrels or anything like that. It is solely up to you whether you want to go through and do that. Now, I will tell you that on these connectors, you can't slide them in. There's notches, so you have to actually pull the screw completely out, lay your wire in the slot, and then put your screw back in. And if you're like me, play around with the screw for a bit because your screwdriver is magnetized. And the nice thing is you don't need to hold it there because it's not going to slide out on you. Once again, there's the load. Red. Neutral, which is going to be your blue. Once again, my load and neutral are marked, but they're reversed from what they are in the manual here, so just be aware of that. But third one will be the ground. Yeah, don't leave don't tin the tips. Leave them bare or ferrules. Either way works. Either way works. Um, I normally just do the bare wire. I don't worry about doing ferrules on these. Coming into these, I will, but for whatever reason, going in the Wagos, I just normally go with the bare wire. So once again, we've got a load. Bring this down in here. Bring these wires out. We'll get to them a bit. We'll bring our load down. Once again, our loads are all right down here. Pop one out there. Kind of figure out where I'm going to go as far as length. And then I can cut this to length. So there's no sense in leaving these longer than they need to be. So and on your Wagos, you want to remove 11 millimeters of your insulation. Give it the little pull test. Do the same thing with our neutral. Bring it over here, get our length, cut, grip, and insert. And give me 1 second here. I just untied my shoe, and if I'm not careful, I'm going to break my neck. Yeah, by going through and doing this stuff today, hopefully that means on Saturday, we'll just be into doing um, configurations, do the software configurations, get everything done up. How's it going, Poon Dog? Hope you're doing well. Hope you are doing well. Sounds good. Bring this one down. Go through the same one, bring it straight across, and we'll need it cut about there. Yeah, this is just I'm not working today, so I figured why not do a little bit of wiring, get some of the wiring done for the build. I was specifically wanting to get the tool head done, which we got the tool head done, and we got that all lined up now. And so we're just working through some of this other wiring so that Saturday we can get into configuration and maybe push a little bit of plastic. All right, so there's our 110 wiring done. See what's next on the list. Oh, apparently somebody decided to be helpful and just scared the bejesus out of it. Okay, so we have some ground wires to put in place. We had the safety ground for the frame and the den rail. So the frame and the den rail. So the den rail, we're going to bring from our AC load side. It says to join it right here. Since we don't have a PS5, I'm going to bring the ground back here to the common ground. Just doesn't need to be done the other way, and that's a or button head. I'm doing that blind, but that's tied in there. I guess I could just unmount this to make sure I did get that in there right. That is nice and good and tight now. Now we can just bring this down. Got our protective earth. This will come down, this will come in. That's fun. So bring this one. We're going to bring this one to this first one right here. So we'll cut this short. Now we do need to make a ground wire for our bed. Remember, our bed just goes to the Wagos underneath here. So we do need to cut one and route it the full length, which I forgot to do, but we can get that in there. That's no problem. But we're going to have to create one of our own, simply because the wire that came with it was not going to be long enough. And I need just so how are you doing, Poondog? Doing anything fun today? Okay, so now we've done these two things. Now we still need to do our frame. Preferably, you'd want to scratch all of your anodizing, or in this case, it's not anodizing, it's powder coating. You want to scratch off to get the bare metal and then put it underneath the screw. I'm going to have to do that. I'm going to have to figure that out here later as to how I want to ground the frame most appropriately, so that we get a good ground connection on the frame and we're not, especially because of the bed and stuff, shocking ourselves on the. But I will have to do that frame grounding here, or via a different, not a different method, but at a different time, because I'm going to have to figure out the best place where I want to do it and then scratch off the paint wherever I'm going to put it at. Now we're going to start powering up our PSU, which we've already done. We've already done our load and our neutral. We don't have to worry about anything else. We do need a load coming from the SSR to our load, and we have SSR wires here. And we've got two wires, not sure why, will come out of our AC load side number 2, go over there. So that up, about sliding this up underneath. Doesn't feel right, so I'm trying to. Well, it was done right. Again, making sure that we're underneath, that our connection's good. We are. Guess while we're at it, the load side is the one that we marked. This is going to be um, the side that comes over to the 1 terminal on our SSR. Earth, print bed. So the side that is darker in this goes through the fuse. And yes, the darker side comes into our load. So we're going to take this off and put a port terminal on it. Um, Server Monkey, have a good one. Thanks for hanging out with me today. Like I said, this is very much an impromptu stream just because well, it's been cold and nasty outside, so didn't really want to go out and do anything in the outside unless I had to, which I know I have to, Mrs. Dragon, if you're listening. Just I don't want to be out there all day when it's cold, so we're gonna wait for it to warm up. So that in there. Okay, bed's there. One side of the bed's there. The other side of the bed will go to the neutral, and this load is going to go over to the load. Not load to load. This will be neutral, so it'll come over to the neutral. I am going to loop it in here. Now on these wires, sometimes they come off cleanly. Sometimes they come off with frays. That you can cut that fray off, and then you can either put a little bit of heat shrink tubing on it to keep it from fraying further. You can leave it alone, or you could put a whatchamacallit, a ferrule on it. I'm going to actually just leave this one alone as it is because I think once it goes in there, it will pretty much stay in place. Those, those are done. Going to come over once again to our load. Okay, so that one's done. And what else? What's next? Power to the controller board. So PSU to controller. And once again, we won't need all of this because we only have the one the one controller or one PSU. We don't have two PSUs. However, we do have an option here because our depends on how we connect up our bed. So if we're connecting the bed up to the bed connector, then we have to provide power into the bed connector. If we connect our bed up to or the SSR to trigger the SSR to HE1, then we don't need to um, terminate anything into the actual bed connector. Just something to be aware of. I'm going to step around here so I can see things here. So my negative is on this side, so that will be my black key. Makes the other two my positive, be a red cable. You only have two power power outputs on your PSU when you use the UHP. So if you do need additional power, things that require the power, you can just bring it out to a Wago and do some Wago mounts on the DIN rail. So here's our positive and negative. What I need to do is figure out which one of these terminals I'm going into on the board. So do I have a Manta M5? Yep, do not. Manta. Go up here, find all. So high voltage N is this first one that's right in line with the motors. That would be, or we got an ad. Okay, there we go. So this first large terminal here is high voltage N. We would use that. Let me bring you guys closer. So this is high voltage N. It's right in line with the motors. We would use this if we were providing higher voltage into these motors and running like 2240s or 5160s. And we're not, so we don't need to worry about that. And we do have all of the jumpers set on our motors to be taking standard board input. So from here, we'll have HE1 and HE0. So we're going to use HE1, first one up here by this lone connector, to trigger the SSR. And then we'll have the HE0, and then DC in and heat bed in, or heat bed out, my bad. So we're going to be using this connector for DC in, and the side next to the capacitor, right, the side that's right next to the capacitor is the ground. So it's ground next to the capacitor, and then red or VN on the other side. Okay, that's how we're going to connect that up, and we'll use our flathead screwdriver to undo our terminals. And so once again, ground is next to the capacitor. So we'll line up our barreled end. and tighten that down. Give it a tug, make sure it's good. Then we'll bring our power in, and that's going to be next to it. Tighten our terminal up, give it a tug, and that's in. Now what we can do is just pop the lids off here and route our cables around in our cable trough. Just like that. We'll leave that open because we'll do some other wiring here in a few minutes. We have the power to the controller. We don't need separate power to a Raspberry Pi because we're using a CB1. We need to come out of the SSR, or for the SSR, so controller to SSR wire now. And you may need to change connectors on this depending on how it connects. I do not like using ferrules under the terminals here on the SSR. Technically you can, but I would prefer a fork connector, so I'll swap these out for a fork connector on one end. And then the other end, we are going into a screw down terminal, so using the ferrules perfectly fine. So I'm just going to cut the ferrules off of the other side and put on some fork connectors or spade connectors, however you want to call them. And I need to grab some because I'm out of that end, or I'm out of the ones over there, or in my kit already. I just need to grab some from underneath here and refill it. Bear with me 1 second. Something else I tend to buy in bulk and have sitting around. Just for giggles, make sure that they will fit underneath your screw terminals, or if you have to change a size. These do fit, so that's good. How's everybody else? Anybody else doing any fun things today? I guess I should ask, who all had to work today? You just had some cauliflower crust pizza. That sounds awesome. And I do mean that sincerely. 'Cause I am also somebody that has to, pizza dough and stuff does not sit well with me anymore, but cauliflower crust does work pretty good. So what we're doing here is we're just matching up positive and negative based on the inputs of our SSR. And then we need to figure out our positive and negatives here. Once again, we're going to go into HE1 on our controller. And HE1 is the one closest to our high voltage in. And then we will go what? The positive side is towards the capacitor. Negative side towards the high voltage in. We're just going to bring these in and plug them in. In the negative or the switched line towards the high voltage in, and the positive will go towards the capacitor in HE0. To make sure everything is staying in place. And then we will route these as appropriate down and through our cable trough. Okay, we still need a JST connector here. This is once again for our Y-end stop. So we'll need to do a couple of JST crimps, but I think everything else from the under the whatever wiring kit is done. We'll need to create some extensions for our bed thermistor and then crimp these and get those over here and plugged in, and then we'll be good there. And I think that's going to be it for now on the bed wiring, because the rest will be, or I mean on the wiring, because I think the rest is just CANBus. I do have some lights that I can put on this. I've got one disco stick. I don't know why there wasn't two. There's only one. So my assumption would be that would be along the back edge. Or I can try and get a second disco stick and put one on each of the front edges or the side edges. I don't know. We'll see how I want to do that. But the rest of that wiring, I think we can do later. The next thing that we would do would be, see, we'd have the display that we'll need to plug in and route up here when we do clipper screen. We'll have bed thermistor, the X or YN stop. We'll run a network cable out and around. Yeah, I think the next step would be just starting on configurations, software install and configurations. So I'm going to probably call this stream. Partly because it's warm enough, and I think I heard Miss Dragon go outside, so I need to make sure and go join her so I don't get myself in the doghouse. So I've got a couple of extra wires here that we will use. Like I said, I still need to add the ground wire to the frame, which we will do at some point. And I need to run a ground to the bed, which I will have to fabricate that wire and then mount the switch, which is the last real thing to do. Yeah, I think I'm going to go ahead and call the stream here, and we will work on this some more on Saturday. But yeah, let me see if there's anybody I can raid out to. Who may be on. Free Heathen is up and running. Let's actually let's see. He's been running for about 2 hours. I think I'm going to raid over into him. All right. So yeah, folks, I'm going to go ahead and get the raid. I'm going to do these last couple of wires off stream. I need to go help Mrs. Dragon, and then I will come back and finish these last couple of wires up, and then I'll say reconfigure the Dragon Den for work tomorrow. But thank you everybody for joining me today. I know it was an impromptu stream, just kind of a hey, let's do some wiring and do some things. I appreciate everybody that came out here and joined me today. And I will see you all tomorrow night for my regular scheduled stream. I'm going to go ahead and get the raid started here. And please join me as we run over to Free Heathen. And chances are he'll drop out into Moko Main in a little bit. Thanks, everybody. We'll see you tomorrow. And then tomorrow for the droid build. Thanks and have a great one. Now.